All right, let's look at some laws of indices and terminologies around it. So if I write down 3 to the power 4 is equal to 81, we refer to 3 as the base and 4 as the power or the index, and well, 81 is just an answer. So what does it actually mean? It just means that 3 to the power 4 actually is 1, 2, 3 multiplied by itself 4 times. I use brackets just to not confuse with the x and times, but you can. So for example, if you've got I to the power of 5, it is 8 times 1, 2, 3, 4, 5 of them. Yeah. Cool. Now all these actually have laws governing the powers, and there's 8 in general. And let's start off with the first one. So the first law is base x to the power m times base x to the power n is you add the powers if you have the same base and you multiply it. For example, a to the power 2 times a to the power 3 should give us a to the power 2 plus 3, which is a to the power 5. Let's check. So a to the power 2 is a times a, and a to the power 3 is 3 of them. So if all of them are multiplied, you end up with 1, 2 from the first one, 1, 2, 3 from the second one, and you end up with a to the power 5. That actually makes sense. Let's do some examples. Okay, so 4 x to the power 2 times 3x to the power, let's say 7. Cool. So what you do is just multiply the numbers together, you get 12. Same base, add the powers 3 and 7, or 2 and 7, you get 9. Done. Okay, cool. Let's move on to the next one. So the second law of indices is if you divide powers with the same base, you subtract the powers. Right, so how does it work? So for example, you've got a to the power 5 divided by a to the power 2 equals a to the power 5 minus 2, which is 3. So if you put that in expanded form, 1, 2, 3, 4, 5 on top, 1, 2 at the bottom, and since they're all multiplied, you can cancel. You're left with 3 of them, and it's a to the power 3. It's pretty straightforward. Let's do some examples. 4a to the power 5b divided by 2a to the power, let's say 4. Cool. So 4 divided by 2 is 2. 5 minus 4 is 1. Cool. There you go. What happens if you have the bigger power at the bottom? So that's the first one. Oops, sorry. The second one is, let's say, 3a to the power 5 over a to the power 8. Ooh. So 5 minus 8, you can actually do 8 minus 5. I'll come back. That's another one of the rules, but 8 minus 5 is 3, so it comes to 3 over 8 to the power 3. We'll look at this one in another video and see how it actually makes sense. Cool. Moving on. Alright, so I'm trying to combine two of the rules in here. Pretty much, if you look at it separately, x to the power m to the power n is equal to x to the power m times n, which you can see on top. And if you have a prefix in front of it, or coefficient, that actually attains the power as well. As you can see, I has the power n, and then I has at the moment here power 1. 1 times n is n, and so on. So let's try and see if we can make sense of this one with some examples. Okay, so if I just do a simple one, like for example, b to the power 3 squared is the same as b to the power 3 times b to the power 3. Add the 3 up, you get b to the power 6. Shortcut 3 times 2 is 6. As you can see, it pretty much makes sense. Example 2. If you have something like 3, let's say m to the power 5, let's say. So if you simplify, that will be, actually no. Hang on. Yeah, okay, you can do that. So it becomes 3 to the power 5 times m to the power 5. And so 3 to the power 5 is 243 m to the power 5. Okay, so let's try another one using the same rules. So if you have something along the lines of, let's say, 6 m squared n to the power, let's say, 4. So if you spread it over, it becomes 6 to the power 4 times m to the power 2 times 4 is 8. N to the power 1 times 4 is 4. So you can figure 1, 2, 9, 6, m to the power 8, n to the power 4. Let's do another one. 2, a, 5, b, 4, 3. Okay, so 2 to the power 3 would be 2 to the 4 is 8. A and 5 3 is 15. B 4 3 is 12. Alright, let's look at the next one. Okay, so negative powers. So a negative power simply means the reciprocal of. And so what does that mean? So example, if I go, let's say 5 to the power negative 2. So what you simply do is you take 5 to the power, take the negative out, 5 to the power 2 and put it below in the denominator, 1 to the power 1 over 5 to the power 2, which if you want to simplify is 1 over 25. That's one. Let's try some more. If you have, let's say, 4i to the power negative 3, so then what you do is 4 is intact on its own, I is to the power negative 3, therefore you flip the I down. So the negative, when you remove, it becomes simply 4 over I to the power 3. And that's it. You can flick this. How about if you have a negative in the denominator? Okay, so let's have a look. So for example, if you've got, let's say, 5i over b, let's say 5i to the power minus 2, b to the power minus 6. If the question says write the answer in positive powers only. So one of the rules of thumb is you do not leave your final answer as a fractional power, which will come to, and as a negative power. Therefore, this is b. Therefore, you have to always make sure the powers are positive. So you have to flip. Put the I down, take the b up, you end up with 5b to the power 6 over I to the power 2. That's pretty much it. So let's move on to the next one. The next law of indices is to do with roots and fractional powers. So if you have x to the power 1 over something, it's the nth root of x. For example, you might know, for example, if it's x to the power half is the same as square root of x. Now for square root, we don't write anything in here. It's 2, but it's understood. Whereas if it's like x to the power 1/3, it means the cubed root of x. For example, the cubed root of 8 is equal to 2. 2 times 2 times 2 is 8. Cubed root. Cool. Now, if you have x to the power m over n, for example, so if you have, let's say, let's say if you've got a to the power 5 over 2, if you want to write this as a power and root, it becomes the number on top numerator is the power and the denominator is the root, pretty much. So square root of a to the power. So about a to the power 7 over 3. So that means a to the power 7 cube root. Cool. So you can flick from one to the other. If you have a number, for example, 125 to the power 1/3, can be written as the cubed root of 125, which will give you 5. Let's try some examples on simplification, on compound ones. So if I have something like, I say simplify, let's say square root of a over a to the power negative 2. You can see I've combined rational power, root, and a negative power. So we can flip the a on top, which will be square root of a times a squared. So square root of a is to the power half, which is a to the power half times a squared. Aha. When you have the same base and you have different powers, what do? You get them up. A to the power 2 plus half. And you end up with a to the power 2 plus half is 2.5, which is 5 over 2. Usually you don't leave your final answer in a fractional power, therefore you write down a to the power 5 root. So both are correct. That's correct, but this is more correct. And the last law of indices is quite important. There is anything to the power 0, anything to the power 0 is equal to 1. Let's prove that. So if I go x divided by x, both have power 1, means if you use the second law of indices, it comes to x to the power 1 minus 1, which will be x to the power 0. Now if you just use x divided by x, you will cancel, you end up with 1. Therefore, x to the power 0 is equal to 1. Meaning you could have a long complex 3x squared times 56 y to the power 21 over 7 and whole thing to the power 0 will equal 1. Alright, so that wraps up laws of indices basic skills. Let's try some simplification and then we'll stop. Alright, let's try 9x to the power 4 whole thing to the power negative half. So first of all, you split the half, it becomes 9 to the power negative half times x to the power negative 2 when you multiply 4 times negative half. So you can put both of them in the denominator. It will be 1 over 9 to the power half times x squared. Anything to the power half is pretty much square root of 9. So 1 over square root of 9 times x squared, which gives you 1 over square root of 9 is 3. Sorry, x squared. Let's try some more. Alright, let's have a look at this complex simplification. So normally try and do, first step I try and do is try and get rid of negatives. So if I was to juggle it around and remove negatives, I would have the n at the bottom, so it will be like 36 m to the power 4 over n to the power 6 whole thing to the power negative 3 over 2. Now if I want to get rid of the negative 3 over 2, the negative in there, I'll flip the whole thing. It becomes n to the power 6 over 36 m to the power 4 to the power 3 over 2. Now that's more doable, I suppose. So you multiply the power to all of them, it pretty much becomes 6 is 18 divided by 2 is 9, n to the power 9 over 36 to the power 3 square root times sorry, something happened. Right, times 12 divided by 2 is 6m to the power 6. So the only thing now missing is pretty much simplifying 36, so to the power 3. So that'll simply be, if you like, you can take that out, and that'll be like square root of 36 cubed, which is same as 6 cubed, which is 36 times 6 would be 6, 6, 12, 2 carry 1, 3, 6, 18, 19, 190. So you end up with the n to the power 9 over 192m to the power 6. There you go. Now, the only reason why I did that bit here is because I don't have access to a calculator. You can just plug it in the calculator and check your answer. Alright, that kind of gives you the basics on laws of indices. Thank you.